Hi everybody, my name is Sam and today I'm going to be taking you through a full demonstration of SkyCiv Structural 3D, our full frame analysis software. We'll be taking you through from the modeling to the solving and even running some design checks and how you can use this software to its full capabilities. So we'll also be looking at some shortcuts and some hidden tips and tricks to help you get the most out of the software. So this tutorial will be good for anyone who's new to SkyCiv, who's never used the product before and wants to see what the capabilities are, as well as anyone who's been using SkyCiv but might not know all the tricks and features that are included in the product and want to get the most out of the software. So welcome all to join, and look forward to taking you through this demonstration. Should take about 30 minutes, and you should understand what SkyCiv Structural 3D does by the end of that. So we're going to start just by, this would be the first screen that you see when you do launch SkyCiv Structural 3D. You will notice that this is all available through a web browser, so our products all work through a web browser. That's the platform in which we use. And you can see here you can open an existing product from your existing file manager. You can look at some examples, and you can also upload files as well. So this might be a good place to start if you have a Revit model or DXF file or some existing product that you want to import from. This is also available in S3D. But for now we're going to start a new project, so I'm just going to click out of that. And the first thing I want to do is introduce the user interface. So everything is clearly labeled. In our software we try to make it as intuitive and easy to use as possible. So you can see all the elements for my model here, all the loads. I've got some options here, and then some action buttons like solving and running design checks. And then finally I have some visibility controls here on the right panel. So to start out, we're just going to add some nodes and start to build a model of our structure. So nodes are pretty much the same as most other products. You'll see their XYZ coordinates, so you can tab and enter to put these in. We're in the metric system, but we can swap over to imperial. So if I go settings, I can change that to imperial, and that'll do some conversions for me. So you can see now that that's showing 13 feet. So you can add your nodes that way, and you can then join members by clicking and dragging between the members. But another way, which is a really good shortcut, is the pen tool. So this is a very popular feature. So if I just switch on the pen tool, I'll be able to then create my members much faster and easier just by kind of clicking a node and then hovering and moving out across these XYZ coordinates. So you can see they're mapping to my my global coordinate system. If I hit escape, that'll cancel the draw, and it'll also pick up any adjacent nodes. So you can see there it's picking up relevant nodes that I might want to connect to. So you can see how easy it is to just sort of map out a general basis of my model, and use the pen tool to make the most of that. Another trick I'll show is just the hovering. So if I just hold Control and then select, I can go right to left. It's going to highlight everything within that box that's explicitly within that box. Or I can go, say I just want to change these two members, I can go left to right, and anything that comes in contact with that box will then highlight. So I can use those two options to my advantage. And I'm going to then add some members. I'm going to change the member section ID to section ID 2. So that's introducing a new section type. So I can see here that's now appeared on my legend here of my sections, and I can see I've got the black columns, these green beams, and then maybe I'll also change these to being beams as well. So making the most of sort of the click highlight functionality as well as the multi-edit too, which is letting me change multiple members at one time. So I can start with just something very simple like that, but maybe we want to kind of copy this out. That's a very useful function we can use, which is just Control A and then Control C, and that's copied my structure with my reference node as being this first node. And so if I click this and then this node and then just paste from there, you can see how I can use the copy and paste functionality to make life a lot easier when mapping out my structure. So again, that's picked up that node as my reference node, so I'm going to select this one and paste from there, and do the same here. So we've got a very simple building, sort of starting to take shape, and we're using some of those inbuilt modeling features to make life a lot easier. So now we want to add some support, so we'll just add some supports to the base nodes. I'm using that highlight functionality, and I'm going to click supports. So we do offer a range of different supports. I'll just do fixed, and I'm just going to, as they're all highlighted, I can double click here. Anywhere where you see this icon here, you can just double click if you've got highlighted nodes, and that will import them into that input. So it makes it a lot easier when you want to add a lot of information or a lot of elements to your model really quickly. You can use the highlight to select the elements in which you want to add to. And so we've kind of got the geometry of the model sort of built out. Might want to add some cross-section properties now. So we have some beams and columns. So let's add some information to these cross-sections. So I can just click that to select that section ID 1, or I can go to sections and go to builder and database. So we do support a range of different template shapes. You can also import from the database. So maybe I have W8. I can search. This makes life a lot easier. Or I can maybe for that one we'll submit that, and then for the second section we can just browse through the library and find something within our library database. So we do support aluminium, cold form steel, timber, joists, and of course AISC steel library. And so we'll do a rectangular HSS, maybe something about a 4-inch deep section. And within the section builder you can add custom shapes, so you can add like a second shape, you can do built up shapes, you can add line shapes, you can import from DXF files. It's particularly helpful when you're designing aluminium structures, and then you can save and load them from your own database that you've created over time. So for now I'm just going to hit submit for that. I've also got controls here for my materials. As it is structural steel, I can just submit it as is, but if I did need to change the material properties of that section, I can do so here on the right hand panel. I've also got some other operations such as changing the dimensions or rotating or even tapering the member as well. So there's quite a lot you can do in the section builder, but for now we're just going to stick to library based sections, and yeah, should have pretty much most of the model defined now. We can go to the renderer. This is always a good idea just to get a feel for the structure. These members look a little bit slender, so perhaps it might identify some modeling issues that you might have introduced by you maybe using the wrong section properties, the wrong section dimensions. But for now I'll leave that as is, and we can show how we can optimize our design later down the track to get the most efficient section we can for that particular section ID, which is the columns, the beams. But for now I'll switch back over to wireframe mode. I'm also going to introduce some plates, so just showing some of the plate functionality that's available in SkyCiv. So what I can do is just say I want to add a plate to this whole area. I can select that, hit add plate. Actually they're not a flat plane, so let's do that manually. So I'm going to do 1740. I'm just going to do the edge of the plate, and I'll show you how it automatically will connect to the intermediate nodes as well. And 12. So I've got my plate here. So I've only selected and connected to these outer nodes, but during the meshing process it will auto detect any other nodes, any beams, so you can fully customize and control the way you want to connect those plates to the rest of the structure. So we can do that now just by right clicking and hitting mesh plate, and we can preview it, but you can see it's automatically imported any other relevant nodes. So it's imported 14, 19, 32 and 29. So it recognizes that there are nodes here and there are members here, so it's also detected that there are members there as well. So when I go to mesh, it's picked up and connected appropriately to those nodes and members, so everything is now being supported. Whereas sometimes you might see, if you don't have that input, you'll see a mesh that's not connecting correctly to the beams, but in that case we can see that that has connected correctly. I've also got some advanced toggles here. So for instance, if I switch on the advanced for plates, I can see I've got a whole range of additional parameters that I can control. Diaphragm, so if I did want to make this a rigid diaphragm, that's quite common, I can apply that too. So now this is a rigid diaphragm. Yeah. That also goes for the members. There are quite a few options in my members. So if I select one of these members, I can see now my advanced options. So I've got controls for the offsets. I've got controls for fixities. They were showing previously without the advanced. So I can make this a pin connection. And yeah, it's also probably worth exploring too the different types of members that we can introduce. So by default, members are connected as continuous members. And I'll just show you how this can affect your model and why this is the default selection for type. So if I select those three members, I'm just going to right click and hit join members. So it's just going to connect them all as one single member. And this is set as continuous, and what this means is that if there's any intermediate nodes along the span of this member, it will automatically connect to that member. So as an example, we're going to do the same on this side, and I'm just going to hit J as a little shortcut, which will join them. But this time I'm going to set it as normal. And the difference between the continuous member and the normal member is that the normal member will only connect with the start node and the end node. So you can see here member 14 has a start node of 13 and an end node of 38. So we'll only connect to here and here. So anything intermediate or anything in between that member, even if it is sitting along that member, will not connect. And we'll see that as we solve the model. We'll start to see the difference in the analysis results that you'll get from this member and why that type is so important. And that's why we do leave it as continuous by default, because it will connect nodes automatically despite whether the node is included as a start or end node. And just on that note too, we also support compression only members, tension only members, cable, so you can run full catenary cable analyses, as well as rigid links and joists. So there's some really useful options here. Rigid links in particular are quite useful when you need to sort of offset a load from a member or a node, but don't want to introduce an actual physical member. So that's quite useful as well. Okay, so that's pretty much our geometry of our model complete. So now we'll look at applying some loads. So loads can be wind, snow, dead loads, all the different types of loads that you need to apply to your structure for proper design. So we can do a few different types. So we've got point loads, moments, distributed loads, area loads, which are really useful because they automatically calculate the tributary area, and pressures, which you can apply to plates. So we'll just start by applying some distributed loads. So I'm just going to maybe apply some loads here, making the most of that control drag functionality. Go distributed loads, and as I can see that icon is there, I can double click here. So I'm going to apply that load to all those members, and we'll do minus 0.2 force in the Y. So I'm looking at the Y, and we'll make this a live load. So you can call these whatever you like, and we'll see how they come into play a little bit later. And another little shortcut, so you'll see the loads now appearing here, the distributed loads. I can scroll these up and down, or I can just hold S and scroll my mouse. So that's a nice little shortcut to turn your loads on and off. And I'm just going to apply maybe some wind loads to these members. So I can do the same trick again, just by double clicking there, and we'll do these in the Z direction. That's going to be positive, 0.05, and we'll call these wind loads. So if I scroll my loads back up, you'll see that now we have some wind loads there. And then I'm also going to demonstrate the area loads. Now area loads is a really popular feature. It makes applying kind of pressure loads to structures a lot faster and easier. So we'll apply that to the base here, this first level. And so what I do with area loads is I will start by entering the corner nodes, and I only have to do 4, so just to kind of create this face. So I'll do 5, 28, 21, and you can see the UI is sort of displaying where those loads, where that face is. And a pressure magnitude of, say, 0.1 KSF. And that'll be in the global Y direction. And let's call this dead load. Maybe we'll call it, let's be more specific, equipment A. And so I'm going to just turn that load back on. You can see there's a green sort of pressure applied there. So I'll go over to here to my visibility settings, and I'm going to turn on, well, let's start by just isolating that equipment load. And I'm going to change the setting to equivalent area loads. And this is showing me where the actual pressure is being applied. So I can see it's being applied to these outer members, and that's automatically been calculated for me. I can click this pressure load, and it'll show me that basically I've taken that entire pressure and I've applied it as distributed loads along these members, and I'm getting a 0% variance, which means all the pressure that I've calculated for is accounted for and applied to these members. Now in this case, I'd probably want them applied in the other direction. So this is a one-way load with my corner loads being set there. But I want to apply them to these members here. So the only thing I need to change here is my column beam direction. That is going from 5 to 28, which you can see that there. Whereas if I change that to being 5 to 2 or 2 to 5, and you can enter it in either direction, you'll see it's automatically adjusted now. So I'm applying my pressure to those members in that one-way direction. And it's automatically readjusted. Even if I was to say delete this member, it'll automatically redistribute the force so that recalculate the tributary areas, so that you don't have to. So you don't have to, recalculate these values. It'll automatically work it out for you. And we can change the different types. So we have a range of different options here. So you can do two-way area loads, which you'll see kind of applying it in that fashion. And that little warning was just, you can turn on this option here. So this will automatically detect inner members when applying two-way area loads. You can see now that's worked that out for me. I might want to, if you do sort of see kind of issues like this, say we did have that member still back in there, it will recalculate everything based off that. So now you can see that it's properly applied the two-way loads across all my different bays, which obviously saves me a lot of time. These calculations can be quite difficult or just time consuming to perform. So this is a really great feature to make you easily calculate those, and with confidence here where you've got some variance checks to make sure that all the force is being applied to your frame correctly. We also do column win loads, which allows you to kind of add variance to your pressure, so you can start from one value to another. Open structure loads, and then non-rectangular loads, which might be a little bit more complicated shapes and you want to apply a load to, so that's really helpful. So I'm pretty happy with all the loads that we've applied. Now let's look at some load combinations. So load combinations can be imported from common design standards. So obviously we're doing a US standard here, so we'll load from the ASCE, but we do have Europe, Australia, UK, Canada and India. And when I've loaded from the ASCE, I'm going to just specify what loads my cases, so remember we applied these different load cases, what they actually mean in the design standard. So I'm going to assign this to being live and then this one being win load, and that way it knows how to properly apply the factors to these load combinations. So I'll import those. So now I've got a range of different load combinations based off ASCE, and I'm happy with that, so I'll apply that. And that's pretty much all there is to modeling a structure or a model in S3D. I'm pretty much ready to solve. There are a lot of other helpful features. There's a lot of great right-click functionality that you can do. You can split members, which is quite helpful. And yeah, a whole range of different operations you can run. We've also got things like datasheet, where if you want to see all the different nodes, this is a really easy way you can copy and paste in and out of Excel. obviously a very fast way to model as well. But yeah, just sort of wanted to focus more on the inbuilt features that the UI have in order to make your modeling life a lot easier. So with that being said, we can now continue to solving. So we're going to run a structural analysis on this model and kind of review some of the results that we get back. So I'm just going to hit solve. I have a few different options here. I can do linear static, buckling, non-linear, and I've got some seismic and dynamic frequency analyses I can run as well. But for now, I'm just going to run, let's run a linear static and go back to a static analysis. And this has picked up some issues, so that this is quite helpful. We have two checks on the model that we run to make sure that your model is built in the best possible way. And this is sort of saying that there is a member, it's identified that as a normal member, and that it's not connected. So it's just warning me that I might have set my member to the wrong class, but we did this on purpose because we wanted to demonstrate the difference between continuous and normal. But it is detected that and said, hey, these nodes aren't actually connected, but they're in between the member. Are you sure you don't want to connect them? So it's a really good sanity check, but we're okay with that. We know that that's the case. We wanted to do that to see the difference between continuous and normal. But it's good to have that sort of secondary check because it'll also give you, warnings if some of your input's not reasonable. So do some dimension checks. For instance, if you've entered in your cross section as millimeters and it should be meters or something like that, it will sort of calculate perform some logic checks as well to ensure your model's built correctly. But we can see we've run the solve and the analysis has come through successfully. So now we can start reviewing some of our results. So I've got all my different load combinations, also the individual load cases, and then finally some envelope cases. So these are really, really helpful. These will give you the worst case scenario in all my load combinations. So I'll run all of them and then just select the worst case. So we're going to use this envelope max, which will give us the worst case scenario. We've got reaction forces, so we can see all the different reactions at the base of our structure. And again, these are the worst case scenarios. We can see our shear force diagrams. You can see, you can kind of select different areas or highlight if you want to sort of isolate certain members and just see their forces. We've got some moment forces as well. And so you can toggle the different values. We've got some really helpful inbuilt stress calculation checks as well. So here you can see some are highlighting red, and what that's indicating is that some are performing, basically we're checking the material's yield strength. So we can check here. We'll check this summary because it's also in the summary. So what we're doing is we're checking any members being stressed beyond their yield capacities or their strength capacities, and we can see in both cases that is the case. So member 25, for instance, that's the governing member and even the load combination. So it's going to give me a snapshot of my structure and just tell me, generally how is my structure performing, and I can see that there are some issues. It looks like the structure is being over loaded, and that makes sense. We saw in the renderer that there was quite a lot of slender elements, particularly the beams. So I'm not too surprised to see these utility ratios come through, and we also get some more global displacement of the building itself. So it's H over 10.3, which is quite high. So it's also doing some building checks as well. But yeah, it's a very good kind of sanity check that you can look at. It's checking all the results and then obviously highlighting those members that are sort of susceptible to yielding or going beyond their stress limits. So I can also sort of isolate these members too if I just want to just look at those ones, particularly in larger structures. That helps me just identify those critical members. And yeah, it's a very handy one to look at. We've also got displacement, so we can sort of see how the structure is displacing. And this is where that member versus continuous member issue is showing itself. So we were warned about it. We did ignore it just to show the difference between continuous. So this member here is continuous, and I can see that it's all connecting together and moving together, and it's connected to these nodes and these columns. I'll just toggle that back on. So you can see that a whole part of the structure is moving in sync, and that makes sense. However, this element is a normal member, so it's only connected at the start and the end node, and you can see it's not connected correctly to these nodes here. So it's not supported by the column, and it's not connected to these adjacent beams. So that's why I'm getting that sort of behavior, which definitely makes sense. So we can go back and change that. Just basically switch that over to a continuous member, or I could have just run that repair model when it prompted me when I went to solve. And let's also change some of these sections, so let's see how it affects the sort of stress values. So let's go for a heavier, something a bit thicker, 518, something like that. So now that we've got a deeper section and maybe thicker section walls, then we should see some of those stress values come down. So it's a really easy way, just can come back to the summary and you can see some of these have reduced. Obviously not to the design that we'd want, but you can see how you can quickly just toggle between the model and the results summary just to get a feel for how your structure is behaving. We can also look at some plate results. Now we did use a rigid diaphragm, so we're not going to get any plate results here. Actually we will, sorry. So let's have a look. So we can sort of see the deflection of the plate, but we didn't apply a pressure load to it, so this is just going to be the forces from the structure being applied to the members. But you can review all the different plate stresses and results, and a few settings for that one as well. And then finally you can sort of export a structural analysis report too, which is very handy for your documentation and reporting. There's quite a lot of options here. You can customize it how you like, include whatever load combinations you want, and create a report, PDF report. Okay, so now that we've kind of built the model, we've done some preliminary analysis and reviewed some of the results, let's go on to design the structure. So to design, we can hit design, start design code, and we've got a range of different design standards and elements that we support. So you can do structural steel, cold form steel, we've got timber, so we do NDS, we do Canadian timber, Australian standards, reinforced concrete, again the same with US, Australian, British, Eurocode, a range of different ones. You can actually review them here quite a lot in terms of the design standards that we support. And then we have plate design as well, so you can do slabs and other concrete plates, connection design, and then we have other designs like aluminium or scaffolding. So there's quite a lot of different design standards that we do support, and we're always adding more and keeping up to date so with the latest standards. So feel free to check those out in your own time and kind of see the different standards that we do support. And the great thing with this is it's all integrated, so I'm going to go ahead and select the US standard AISC 360. And what this now does is it's going to import all of my members, all my material properties, all my section properties, all my internal forces that we ran from the analysis, sorry. So really I just can pull in and just hit check right away and I'm going to get some results. So everything is fully integrated, it's very seamless, and you're able to get your results really quickly. So I can see I've got some passing members and I've also got some failing members, particularly in these columns. So I've got, I can kind of filter out these. Let's look at the failed members, so we can see all the failed columns. They all seem to be, very similar the way they're failing. It's this combined action check. I can also review the results. So all of our software, all of our design software includes this functionality where you can review the calculations being performed. So this opens up the black box to show the engineer exactly the calculations that are being performed, the relevant chapters, the relevant clauses, and so we can sort of see where that's failing and why that's failing. So we have a little bit more transparency in our designs, and we know why it's failing and where we can sort of optimize our designs. And that's consistent throughout all of our design software, whether it's concrete, steel, cold form, timber. So you have that clarity and that transparency in your designs. But you can see, that there's quite a few failing. It's mainly the moment in the week axis, so I can also use this to kind of help guide my design decisions. And that makes sense. Maybe we applied the wind loads on the week axis, so even when we're looking at the governing results, we could see it was deflecting to, laterally, so just probably the way we've applied the wind loads. And if I did want to optimize this design, so I do have some failing members, and I say, well, okay, let's try to optimize this design as best we can. So we can run this designer functionality, and I've got some options here, so I can put in some controls for like height limitations if I have some like architectural limits. I can include and exclude some sections as well. So let's just maybe just focus on the 8 to 12-inch range. And then my analysis interval. So basically, if I set that to 1 or 2, it's going to run, so let's say, for example, 2. It will rerun the analysis every second check. So I'm going to check all the sections in that library, and I'm going to resolve every second check. So it will take longer to do that, but you'll get a more accurate result by the end of it. But I'm just going to leave that off and set it to 0. There's more information on that too if you highlight over these inputs. And I'm going to go ahead and run that. So what that's going to do is check all my sections in the library, and maybe actually in this case I'm okay with the HSS sections. Let's just optimize our W shapes. So I'm going to run that, and I'm only going to optimize between the 8 and the 12-inch sections. So you can see the sections that it's testing, and it's retesting all those different sections in my model to try to get the most efficient cross-section to use for that particular member or group of members. And so I've got some results. So it's selected, let's have a look at the iterations that it ran. So it's tested all these. The original was failing at about 2.9, and so it's tested all these different scenarios, and it's found one that it's got a utility ratio less than 0.95, but it's significantly, it's going to be heavier, but that's fine, but we've got a passing model. So this is my most optimal section that I can use for this particular design that still meets the design requirements. So I can go ahead and select that. It's already selected for me, and I can commit that change. And now it's going to resolve and redesign, and then should present me with a passing design. And it's worth noting that if my cross-section was passing by default, then it would have given me the most optimal design that is available. And in this case, we can see that it was failing before. It's got a lot more passing members now. And after we reran the analysis, it would have updated the deflections and then redone it. So basically, that's where this interval analysis comes into play. So I would probably need to use an analysis interval in this model, because it did find a section that was passing, but when I resolved it, it would have been a heavier section. So then it would have caused it to fail the deflection checks. So that's why you can sometimes use an analysis interval of 0, but then if you come back with some results that are failing, then you might want to start playing with the analysis interval and getting it to resolve in between. And I can see now that it's rerunning the analysis in between, every third section that it's testing. So it should have a more up-to-date analysis for each of the sections. So you can see it does take a little bit longer, but it should produce a more accurate result. And to get it to work each time, you would set it to 1. 1 is the best, because we'll always rerun the analysis in between every cross-section. But just for the sake of this demonstration, I think it's just sort of saving some time, just using a higher analysis interval. And you can see the difference that made now. So now we're getting a passing design check, and we're using the section. We're using a W8 by 28. So I had to go a little bit heavier, but now we definitely have a passing model, and that meets all the design requirements. So that's pretty much it from start to finish, going from modeling, loading, solving, and then finally a design check. we can save our design here. So all of our software operates on the cloud. So when I save a model, I'm saving it to the cloud, which I can then visit anytime from any other device. So I can, close out of this model. So let's call it demo 1 or demo 2. And I can open up from a new computer. I don't need to reinstall the software. I don't need to send the file across. Another great feature is if, say, we start modifying this model, or say we're sharing this model with someone and they've made a whole big change here and saved over it. It's actually caused problems in the model, but that's okay. You've also got vision history, so it basically records all the changes that have been made. So if I've made a mistake, I can see that someone's removed 4 members there that shouldn't have been removed. I can revert back to my previous model and restore this version. So it really creates that, single source of truth. Excuse me. So you're always on the latest version. You're not going to have to send models to each other with version 1.2, 0.3. Everyone's always on the same version of the model. You can just see the tracked changes. And kind of see what has changed over time to see the history of the model. And you can also share, even with like ourselves, like customer support, which is really, really helpful. And it also includes the live chat window. So if you do have any questions along the way, this is inbuilt into the software as well, that you can sort of say, if you have any questions with particular features or functionality of the software, you can prompt us and we can help you with that. Otherwise, we do have inbuilt documentation. For instance, all the inputs will have a little eye here, and if you click that, it'll take you to the relevant part of our documentation. That usually includes a video and some more information about the different inputs or properties for that particular feature. And then finally, we have some S3D shortcuts and tips. It's quite helpful to see the different shortcuts. If you're like me, you like using shortcuts, they save a lot of time. But this is a great way where you can get a review or a summary of all those different shortcuts. And finally, just examples and walkthroughs, they're quite helpful too. So you can see, okay, maybe I want to build a portal frame, and here's a really good example with a video, and it just kind of shows you exactly how you would do that in the software. Very detailed, with a video to help guide you along the way. So I hope that's been a helpful demo. And if you have any questions, feel free to send them through. Otherwise, we look forward to having you on the platform soon. Thank you.